Okay, today's lesson is on properties and the different types of properties that we use. So the very first slide that you have here is the chart on your lesson sheet. And as we go along through these different types of properties, you're going to fill in this chart. So as you can see, we've got addition and multiplication is basically what we're dealing with. So let's look here first at the closure property. The closure property is when you are adding or multiplying two whole numbers. Whole numbers is the key word here, or phrase. Okay, they have to be whole numbers. So when we're subtracting or dividing, the result is not always going to be whole. So the closure property doesn't apply with subtraction and dividing. It only applies when we're adding or multiplying. So here's an example for addition. So we're going to go to our chart here and write 6 plus 11 is equal to 17. That means when we add two numbers together that are whole numbers, we get a whole number for an answer. Same thing with the multiplication. If we multiply two whole numbers, any two whole numbers, we will get another whole number. Okay? So it's not really about the numbers here. It's just understanding that if you add two whole numbers or if you multiply two whole numbers, you get a whole number as your result. Okay? The commutative property is the next property. Let's take a look at that. The commutative property looks like this. 2 plus 3 is equivalent to 3 plus 2. It doesn't matter the order because with addition, it's still going to be 5 either way. And the same thing with multiplication. 2 times 3 is the same as 3 times 2, which is 6. You can remember this moving of the digits by thinking of the word commute in commutative, to commute or to move. When they talk on the news about the morning commute, that means people driving to work, okay? And you're moving around. So you're going to want to add this to your chart here. So for example, 2 plus 3 for addition is the same thing as 3 plus 2. You don't actually put 5. We're just showing that you can write it either way. And with multiplication, 2 times 3 is the same thing as 3 times 2. Okay, the associative property looks like this. Notice with the associative property, we have a 2, a 4, and a 6, and it stays in that same order, 2, 4, and 6. What has changed is the parentheses, okay? The parentheses are grouping different numbers together. And with the associative property, you can remember that with the word associate. You associate with different people. So you're going to associate different groups of numbers together. And because of addition, if it's all addition like that, it doesn't matter what numbers you associate and what two numbers you add together first. It's still going to give you the same result. If you add 2 plus 4 first and then add the 6, or if you add the 4 and 6 together and then add the 2 in, it doesn't matter. It's going to be the same. And same thing here with multiplication. 2 times 4 and then multiply by 6, or 4 times 6 and then multiply by 2, you're still going to get 48 either way. So I'm not going to keep going back to that chart. You should be putting this example right here in the addition column and this example right here in the multiplication column. You guys following along?
Yes.
All right, the identity property. Now the word identity, usually when you think of that, you think of yourself and who you are. So with addition, the identity property of addition says that if we add 0 to any number, that number is still going to remain the same. So for example, 1 plus 0 is still 1, or 5 plus 0 is still 5, or 100 plus 0 is still 100. So this is the example you put in the addition column. And then for multiplication, the identity property for multiplication wouldn't be multiplying by 0 because that wouldn't leave you with the original number. For multiplication, you'd have to be multiplying by 1. Anything times 1 is always the original value. Are you getting this added into your chart?
Yes, ma'am.
Perfect. Okay. The inverse. 6 plus -6, the inverse of 6 is -6, gives you 0. That's how you get 0 using the inverse. That's the addition. And this should have an equal sign right here. It's kind of hard to see. This should say 6 times 1/6 equals 1. That's the multiplication. I don't really like this. This is the multiplication example. And that's really like 6 over 1. So if you had 6 over 1 and you multiply straight across, you get 6 over 6, which is just 1. Okay, so that's the inverse property. You're inverting the fraction. You're going from 6 over to 1 to 1 over 6. You just flip the fraction. And when you flip the fraction, every time you're going to get 1. See, watch this. 2 over 5, if we're multiplying by 5 over 2, we would get 10 over 10, which is just 1, right? Every time. By doing the inverse or flipping the fraction and multiplying straight across, you're always going to get 1. Okay, the distributive property. I'm going to give you a minute to write that down, and then I'm going to explain that. Okay, so the distributive property, we did discuss that a little bit last week when we did combining like terms and we had the subtraction sign in between the parentheses. And we had to distribute that subtraction sign to the terms that were in that next parenthesis. It changed all the signs. Do you remember that? All right, so this might be helpful if you would do this on your paper. So see, that's how we get 6 times 8. Because this 6 in front of the parentheses, because it's side by side like that, it means multiplication. So 6 times 8, and then you carry over the plus sign, and then 6 times 10, and that's where this comes from. So that's the distributive property. All right, let's go ahead and apply now what we've just learned. Let's see if we can figure out what these properties are. So letter A, -2 plus 7 is equivalent to 7 plus -2 based on what property? Raise your hand if you can tell us what property you feel would best represent that example there. Jonathan. The associative property? Well, remember the associative property, you're associating different groups of numbers together. Okay, so don't get confused and just see parentheses and think it's going to be associative. It's still the -2 that's in parentheses, but the numbers have flipped. So -2 plus 7 and then 7 plus -2. Yes, that's the commutative property, and you can abbreviate it like that if you would like. Okay, letter B. I'm looking for hands. Mackenzie? Associative. Okay. Letter C. Now this one looks a little different than it did in our notes. Raise your hand if you think you know which property the letter C would be. Isaiah? It is the distributive property. Very good. This 12 here is being broken up into 10 and 2, and you're multiplying the 5 by 10 and then by 2. That makes it a lot easier to do in your head anyways. You may know 5 times 12, but if you didn't, you should know 5 times 10 real quick and 5 times 2 real quick, and then you could add those in your head together. So it's easier if you break a number like 12 up into 10 and 2. Just makes the mental math easier. Okay, and then letter D. Hannah? The commutative property. Good. All right, next. Which of the following properties is illustrated in this equation that we have here? Which of the following properties, be very careful, is illustrated? Harley? Remember with associative, you're associating different numbers together. We still have the 3 and the 5 in parentheses on both sides. What do you think, Harley? Commutative property, that's right. It's the commutative property. If it helps, look at it like this. You've got the 3 plus 5 there, and then the 7, and then you have the 7, and then the 3 plus 5. So those switched places. So it's the commutative property. What other operation, like subtraction, is not commutative? What other operation, like subtraction, is not commutative? Meaning you couldn't switch it around and it be the same. Who knows? Liam?
Inverse.
Well, we're looking for another operation. Riley? Division, yes. Division. So, for example, 10 divided by 5, which is 2, would not be equal to 5 divided by 10, which is... What would that be? No, 5 divided by 10? 5 tenths?
10 divided by 5 is 2. 5 divided by 10 is -2.
No, there's no negatives here. What? 0.5 or 1/2. 5 tenths, 5 out of 10 is 1/2 or 0.5. Those aren't the same. 2 is not equal to 0.5 or to 1/2. Okay, for each of the following equations, fill in the number or variable that makes the statement true and identify the property that we applied. Okay, so letter A, 5 plus -3 is equal to -3 plus 5. What property is that? Commutative. Very good. 4 times 2x minus 5 is equal to 8x minus 20. What property is that?
Distributive.
Very good. Distributive property. You might want to show this using your little firework arrows here, showing the 4 multiplying to the 2x, and then the 4 being multiplied to the 5, which is how you got the 20. All right, and letter C, 7 plus 6 plus 2 in parentheses is equal to 7 plus 6 in parentheses and then plus 2. And that would be the associative property because you are associating different numbers together. All right, I think this is the last one. What is the identity element for addition? In other words, what number can be added to a given number without changing that given number? And explain. Olivia? Well, that's what we're talking about, the identity element for addition. Mackenzie? 0. And we already kind of went over this a little bit. So 0 is the identity element for addition. And if we want to explain, we could just write because 6 plus 0 is still 6. And 8 plus 0 is still 8. Right? Anything plus 0 is still that original number. All right, and then letter B, what is the identity element for multiplication? Harley? 1. Very good, because 5 times 1 is still 5, and 2 times 1 is still 2. It says to explain. You can explain, or you can give an example that explains. Okay, that's the end.